Fractions lecture outline is fraction and its types. We will be studying fraction and its types. We will be studying addition and subtraction of fractions. We will be studying multiplication and division of fraction, and then we will be studying mixed fraction and how fractions can be converted into decimals and its related problem. Now, what is a fraction? What is a fraction? A fraction is a number of the form a over b. Now look at here. This is a number in the form of a over b. Now a is basically numerator while b is denominator. And a and b are integers and b cannot be equal to 0. Because anything in the denominator, if it is 0, then the answer will be infinity. Moreover, in a fraction, a represents numerator, which represents part out of whole, while b represents total parts. So here b cannot be equal to 0. Mixed fraction. Mixed fractions have a whole part and a fraction part. Now, what is a whole part? Whole part. Now, if you observe this fraction here, 1 is whole part while 2 over 3 is fraction part. So this is a mixed fraction. Similarly, this is a mixed fraction where 2 is a whole part while 2 over 4 is a fraction part. Now you can convert a mixed fraction into an improper fraction. 3 multiplied by 1 is 3 plus 2, 5. 3 into 1, 3 plus 2 equals 5 divided by 3. So here I have converted a mixed fraction into an improper fraction where the denominator is less or smaller as compared to the numerator, which is 5. So this is an improper fraction. Similarly, you can convert this mixed fraction into an improper fraction. How? 4 multiplied by 2 is 8 and 8 plus 2 is 10 divided by 4. So here again we have converted a mixed fraction into an improper fraction, where in improper fraction you have numerator larger than denominator. An expression like 4, where 4 is the whole part and 3 over 8 is a fraction part, is called a mixed fraction. It has an integer part, where integer part here is 4, and a fraction part, and fraction part is 3 over 8. We can convert this into an improper fraction. 8 4 times 32 plus 3 equals 35 over 8. Again, this is an improper fraction. Numerator is a larger number as compared to denominator, which is a smaller number. So this type of fraction is improper fraction, and this type of fraction is a mixed fraction. Equivalent fraction. Fractions with same size, now this is important, same size, but with different denominators and numerators are called equivalent fractions. Now observe these fractions: 40 over 72 and 5 over 9. they both have different numerators. Here you have 40 in the numerator, here we have 5 in the numerator, here we have 72 in the denominator, and here we have 9 in the denominator. So we have different numerators and we have different denominators. However, their size is same, as we have mentioned it here, same size. How? 40 can be expressed as 8 into 5 is equal to 40, and 72 can be expressed as 9 into 8, 72. If we cancel 8, your answer will be 5 over 9. So 40 over 72 on simplification can be converted into 5 over 9. So 5 over 9 and 5 over 9 both are same. So 40 over 72 and 5 over 9 both have the same size. If we express 40 over 72 in its simplest form, you will get 5 over 9. So you have same size, but you have different denominators and numerators. So these fractions, or such type of fractions, are called equivalent fractions, where numerators and denominators may be different but their size is same. 1 over 2, 2 over 4, 3 over 6 are all equivalent fractions. How? 1 over 2, and if you will simplify 2 over 4, you will get 1 over 2. If you will simplify 3 over 6, you will get 1 over 2. So upon simplification, your result is same, but in this form, they have different numerators and they have different denominators. So such type of fractions are equivalent fractions. Now, what are improper fractions? I have explained this in mixed fractions also. So fractions in which the numerator is larger than the denominator. Now observe here, if I am talking about 9 over 5, so in case of 9 over 5, 9 is numerator, 5 is denominator. 9 is large as compared to 5. So when numerator is large as compared to denominator, so this is an improper fraction. Similarly, if I will be observing this case, here 7 is numerator, 6 is denominator. Now 7 is a larger number as compared to 6. So I have a larger numerator and I have a smaller denominator. So this is also an improper fraction. Now what about Egyptian fraction? It is the sum of any number of different fractions. Like here you can see, we are basically adding these two fractions. But what is the condition here? Each fraction has a numerator 1. So if you observe these two fractions, in these two fractions numerator is 1. So addition of any number of fraction, addition of sum of any number of different fractions with numerator 1 is basically Egyptian fraction. Now coming towards addition and subtraction of two fractions, when I have to add any two fractions, then the simplest way of adding the fractions is to make denominator same. Now if I will be observing 1 over 3 and minus 2 over 5, which have to be added, so here denominator is 3 and here denominator is 5. So if I want to make the denominator same, then I will be multiplying denominator of this fraction, which is 5, with both numerator and denominator of the other fraction, like I have done over here. I have multiplied 5 with 1 and 5 with 3. 5 was the denominator of this fraction, and I have multiplied its denominator with the numerator as well as the denominator of the other fraction, like here. Because I have to add them, so I will be inserting an addition sign over here, and now I will be working on this fraction. And if I want to make the denominator same, then I will repeat the process. I will multiply 3, which is the denominator of first fraction, with both the numerator and denominator of the second fraction, like this. I have multiplied 3. This was denominator of my first fraction, this one, with both the numerator and denominator of the second fraction. So upon simplification, 5 into 1 is 5, 5 into 3 is 15, 3 into minus 2 is minus 6, while 3 into 5 is 15. So now I have got the same denominators. Now I can take my LCM. Having the same denominators, you will write the denominators and you will add the numerators as they are. If you have same denominators, you can take them as LCM and you will be adding the numerators as it is. So 5 minus 6 is minus 1 over 15. So this is the answer for the addition of these two fractions, and the process is to make the denominator same. Now we can do the subtraction in the same way. I have to subtract these two fractions. Again, we have to go through the same process. I will make the denominators same. How? I will multiply this 5 with both the numerator and denominator of this fraction, and I will multiply 7 with both the numerator and denominator of the other fraction, like here. If I will be multiplying, I have been multiplying 7 with 3 and with 5. I may be writing 7 over here, so you can write 7 over here. If you can write 7 over here, and because I am multiplying 5 in the numerator as well as in the denominator, so you can write 5 over here. So 7 with numerator, 7 with denominator, 5 with numerator, 5 with denominator. Now this 7 is basically the denominator of which fraction? We have to observe it very carefully. 7 was the denominator of the second fraction, and I have multiplied 7 with both the numerator and denominator of the first fraction, while 5 was the denominator of the first fraction, and I will be multiplying 5 with both numerator and denominator of my second fraction. Here you can observe this process. This was my second fraction, and I have multiplied 5 with both numerator and denominator, and this was my first fraction, and I have multiplied 7 with both numerator and denominator. Upon simplification, you will be getting here 21, and you will be getting here 10. So 7 5s are 35, 7 5s are 35. Now I have the same denominators, both are 35, so I can take the LCM now with the same denominator, and I will be adding the numerators as they are. I will be adding 21 plus 10, which is equal to 31. So 31 over 35 will be my answer if I can simplify it further, but it's not possible over here. So this is my answer, 31 over 35. That is basically the result of addition. Do we know, basically we are performing the subtraction over here, so I will be going to subtraction over here, right? So I have to correct over here that it is a subtraction. This is a subtraction. So again perform the correction over here, and you have to subtract here. So when you will be subtracting 21 minus 10, you will be getting 11 over 35 as your answer. Now when I will be multiplying and dividing the fractions, so what will be the process? When you will multiplying the fractions, like here, multiply 3 over 8 and 4 over 7. So in case of multiplication, numerator will be multiplied with numerator. 3 multiplied by 4 is 12, while denominator will be multiplied with denominator. 8 into 7 is 56, and upon simplification you will get 3 over 14 as your answer. However, in case of division of fractions, when you have to divide these two fractions, you basically you have to convert this division sign into multiplication sign, and upon conversion from division into multiplication, you will be taking reciprocal of this second fraction. Reciprocal mean you will be interchanging the numerator and denominator. 4 will be coming in the numerator and 3 will be going into the denominator. So instead of 4 over 3, after inserting multiplication sign, it will become 4 over 3 from 3 over 4. Initially it was 3 over 4 when division was here. When I have inserted multiplication sign, it become 4 over 3, which is reciprocal of 3 over 4. Now because I have multiplication sign over here, you can multiply numerator and numerator. 17 into 4, and you can multiply 8 and 3. But here I have performed simplification. 4 can be cancelled with 8, so I will get 2 over here. So 17 over 2 into 3, which is 6, will be my answer. Now in next case, that is basically fractions when expressed as decimals. So you can say that multiplication of decimals. Now you can convert fraction into decimals by using division method. So if I have to evaluate 14.72 and 1.2, these are both decimal numbers, I can express them as fractions also. So first of all, I will be multiplying these numbers by ignoring first the decimal sign. So I will be multiplying 1472 and 12, like here, 1472 into 12. So upon multiplication of 1472 and 12, your answer will be 17664. This is a result of multiplication of 1472 and 12. This is the process. So 17664 is my answer of multiplication of 1472 and 12. Now I have to insert decimals in my answers. If you can see, I have inserted decimal over here. Now what process I have followed over here? I have counted how many digits were there after the decimal point in my question. Now here I have one digit, that is 2, after the decimal point, and I have 2 digits here after the decimal point. So in total I have 2 plus 1, I have total of 3 digits after the decimal in my question. So I will be inserting decimal at a point at that place where I will be getting 3 digits after the decimal, as was the case in the question. So this is an easy way of multiplying the decimal numbers Now I can take another example related to multiplication of decimal numbers. If I want to multiply 130.4 and 0.15, so multiply 1304 without considering the decimal and 15 without considering the decimal. 1304 into 15 is 19,560. Now this is my answer, but I have to insert the decimal in my answer. So now count the number of digits after the decimal in the question. Here my decimal is right here, and I have two digits, 1 and 2 here, and I have one digit after the decimal here. So in total, one digit from here and two digits from here. I have three digits after the decimal in the question. So I will be inserting the decimal at that place where I can have three digits after the decimal. So this is the process of multiplication of decimals. Thank you so much.